Hello and welcome to this Alibaba Cloud Academy online certification course on cloud computing. We'll be starting with ECS basic concepts. Let's first take a look at the Alibaba Cloud portfolio. Alibaba Cloud offers a wide variety of services in big data and AI, databases, middleware, video processing, IoT, application services, security, even private cloud, but we'll mostly be focusing on IaaS, or infrastructure as a service, in this course, starting with Elastic Compute. Alibaba Cloud's Elastic Computing service is called ECS. The Elastic Compute service offers an SLA of 99.975% for a single virtual machine, which is very, very high, 99.995% for multi-zone virtual machines, and our Elastic Compute service is deployed in all 22 of our worldwide regions. Our machines all use modern Intel Xeon CPUs, sometimes with CPU frequencies up to 3.2 or even 3.8 gigahertz, and you can initialize or release up to 100 of these virtual machines in as little as 10 minutes. We offer many different classes or families of ECS virtual machine based on your workload. So we have general purpose instances, compute optimized, memory optimized, high clock speed, local SSD, big data, and even an SAP instance type specifically designed to run SAP S/4HANA workloads. This is enabled by our third generation virtualization technology, which we built ourselves, which we call xDragon, which gives us almost zero cost on the virtualization layer, so these virtual machines run as though they were your very own physical machine. Billing for virtual machines is very flexible. You can purchase the machines on a pay-as-you-go basis, paying per hour, or you can purchase an upfront subscription for a month, 2 months, a year, or even 3 years. We also offer a variety of heterogeneous instance types that are designed for workloads that require special purpose hardware. The heterogeneous computing types include instances that offer a GPU or an FPGA card. We also have bare metal instances which have no virtualization layer. These are a great choice for running your own virtualization scheme like VMware or Microsoft's Hyper-V. And then we offer HPC, which is a high-performance computing instance type which can be used to build supercomputing clusters. The advantage of the HPC instance type is that it has built-in RDMA support and very high-speed convergent Ethernet connectivity. These instance types are designed for things like very high-speed media transcoding, industry simulation, rendering, or even genetics. If you're still not 100% sure what ECS is, this next part is for you. ECS stands for Elastic Compute Service, and this is a flexible on-cloud computing service that you can use to launch virtual machines. That's what it does. An ECS instance is essentially just a virtual machine that lives on Alibaba's public cloud. The advantage of this is you get a lot more flexibility, stability, and security than you would get in your own cloud environment because you benefit from all the work Alibaba has done to improve and grow its public cloud offerings, to improve its own security, and to provide stable service. So an ECS is a virtual machine that you run on Alibaba Cloud. If you compare ECS with a traditional off-cloud deployment, the key benefit is operations and maintenance costs are lower. So for an ECS instance, physical server management, storage, physical networking configuration, power, cooling, and virtualization, these things are all Alibaba Cloud's problem. You don't have to worry about them. You only worry about launching your virtual machine, logging into it, and setting up the software that you want. So you get lower O&M burdens by moving to ECS. Another key advantage not mentioned here is, of course, flexibility. Unlike a physical server, you can create a VM and destroy a VM anytime you want without waiting. If you buy physical hardware, you're then committed to that hardware even if you end up not using it. So cloud deployments can, in fact, be cheaper than off-cloud deployments. What really makes ECS work is virtualization. So in Alibaba Cloud, we of course have multiple data centers around the world. In each data center, we have racks and racks of physical servers. Each physical server is running Linux, and then it's running a virtualization layer. In many cases, it is kernel virtual machine or KVM. When you launch an Elastic Compute Service instance, an ECS instance, what's happening is we are creating a KVM virtual machine and launching it on one of these physical servers inside of our data center. Because your workload is living within this virtual machine, It can be moved around between physical machines as needed, which helps us make sure that your compute service is fully reliable, because if a physical server fails, we can simply migrate your virtual machine to a different physical server that's healthy. In order to do all of this migration and management and decide where to schedule your virtual machines, we have to have a management layer running on top of our cluster of Linux machines inside of our data center. We call this layer Apsara. In Chinese, it's called Feitian. Apsara is our self-developed distributed system for managing our cloud platform. All of our products are built on top of Apsara. Essentially, Apsara handles storage, scheduling, resource management, and distributed coordination for all of our products that run on our public cloud. You can see some of the components of Apsara here in orange, and then our public cloud products running on top in gray. In particular, Tangu, our distributed file system, is a key component of all of our storage services, including storage for our ECS instances. So when you allocate an ECS instance disk, that's actually running on top of a distributed file system, which gives you extra reliability over and above what you would get with a single physical block device. Currently, Alibaba Cloud has 22 regions across the world and 66 zones. ECS is available in every single region and zone, no matter where you are in the world. So US West, US East, our data center in London in the UK, in Frankfurt in Germany, in the Middle East in Dubai, in Hong Kong, and our many data centers in China, all of them support ECS. So wherever you happen to be, you can make use of ECS. Within each of those regions, we have multiple data centers. So for instance, in Hong Kong or in Singapore, we have multiple zones. Each zone is a physical data center with independent power and network connectivity. Fault isolation can easily be performed between zones, so if a single zone fails, the other zones in the region are not affected. Because each region contains multiple zones, it's possible for you to build failure-tolerant architectures by deploying multiple ECS instances into each zone. For instance, in Singapore, if you're running a web application, you could deploy an ECS instance in Singapore Zone A, and then deploy a clone or a twin of that ECS instance in Zone B. If Zone A were to fail, the instance in Zone B can continue to serve requests. How do you decide whether or not to build a multi-zone architecture? Well, you have to make a trade-off between network latency and high availability. If you want high availability and you can tolerate a slight network latency, then you go with a multi-zone deployment. If you have to have the absolute fastest communication possible between all of your VMs, then you put them all in a single zone. So it's important to understand the network topology, the connectivity between regions and zones. So within a single region, all of the zones are connected together over Alibaba Cloud's private network, and traffic that passes between the zones within a region is free. So if you communicate over our private network between an ECS instance in Zone A and an ECS instance in Zone B, both in Singapore, then all of that network traffic is free. However, if your instance in Singapore needs to talk to an ECS instance in Beijing, that will not be free. You will incur a public bandwidth charge for using the public internet, or a VPN gateway charge for having a VPN tunnel, or a CEN network charge if you choose to use our enterprise multi-region private network. We do have a private network between our regions, but we charge you for bandwidth if you use that multi-region private network. That's a major distinction. Again, within a single region, zones can communicate with each other over the private network for free. Between regions, you either have to use the public internet, a VPN gateway on top of the public internet, or our Cloud Enterprise Network, CEN, which is a paid private network product that connects multiple regions. So when you're planning your architecture, plan ahead what region you should place things in. If you are going to build a multi-region deployment, think about how you're going to connect those regions together. We next turn our attention to ECS instances. So an instance is a virtual computing environment. We can call it a virtual machine, which includes CPU, memory, storage, and the other fundamental components required to run a modern operating system. That is what's presented to you, the user, when you create an ECS instance from the Alibaba Cloud console. Now, the ECS service provides a wide selection of instance families and types, optimized to fit different use cases. Instance types comprise varying combinations of CPU, memory, storage, and network capacity. There are a few types here at the bottom of the slide that are fairly common instance types. There's the burstable type, which we call T6. That's the 6th generation burstable type. General type, G6. Compute optimized, C6. And memory optimized, R6. We'll talk about what some of the differences are between those different instance families later on. So to understand the instance naming conventions, we have an example here. So all ECS instances will start with the prefix ECS. So all instance names start with ECS and then a period. After that is the instance family. So this will indicate the ratio of vCPU to memory and any special hardware that the instance might include. And the instance family will also include the instance generation. The generation number increments over time as we add new and better hardware to our data centers. So right now the newest hardware is the 6th generation Alibaba Cloud Server hardware. So G6 indicates that this is a general purpose 6th generation ECS instance. What does that mean? Well, general purpose instances have regular x86 server hardware and they provide a vCPU to memory ratio of 1:4. So for every CPU core in a general purpose instance, in a G instance, there will be 4 gigabytes of RAM. The instance type is all the way to the right. This indicates the actual specification of the instance. How many vCPU cores does it have? An X large would have 4 vCPU cores, so a 3X large would have 3 times 4, 12 virtual CPUs. So we can expect this instance to have 12 virtual CPUs and 4 times that much memory, because a general purpose instance will have a CPU to memory ratio of 1:4, so we can expect this instance to have 12 vCPU cores and 48 gigabytes of RAM. Now there are a variety of different instance families to choose from based on your workload. Here we do our best to summarize the common x86 based server hardware that's available. So we have the T6 and S6 class all the way to the left. These are for light workloads. These instances have a CPU usage cap or a limit. These are intended for workloads that are not CPU heavy, maybe a small website or blog or a testing or development platform. The T6 and S6 instances accumulate CPU credits during times when they're idle, and these credits give the instance the ability to burst. That's why we call them burstable instances, up to 100% CPU usage for a certain amount of time. So one CPU credit gets you 1 minute of CPU time at 100% utilization. So what happens when you run out of credits? Well, your CPU usage gets throttled back down to some baseline. So these instances are not really where you want to be running an important production workload. They're really for light usage. Then there are the G and C type instances. These are general purpose instances for more compute intensive workloads. They do not have a CPU limit. You're not throttled down. You could use these maybe as back-end servers for a website or for a mobile platform. They're very general purpose. You could use them for serving ads, for video encoding, really any type of task. Then there are the D-type instances, the D1 and D2 here. So there's the D2S and D1NE. These are enterprise instances for big data applications. This is where you'd want to run Hadoop or HBase or MapReduce. If you had a Spark in-memory computing job, you could run that on these instances as well. They have a lot of RAM and they have local disks for high-performance disk throughput. Then there are the R5 and R6 and RE6 instances. These are memory optimized. These have a vCPU to memory ratio of 1:8, so you get 8 gigabytes of RAM for every virtual CPU core. These are for high performance in-memory databases, data mining, SAP, basically any memory-heavy workload. And then there are the I instance classes. These are for I/O intensive workloads. These typically include super fast local disk. So these have high-speed local disk storage that you can utilize to accelerate applications that require high-speed persistent storage. Then any instance with an H in the name from any of these other classes, any instance with an H in the name is a high clock speed instance, so it will have a higher CPU clock speed. So for instance, if you saw maybe an HFG6, that would be a high frequency general purpose 6th generation instance, so it will have the same CPU to memory ratio and same hardware as the regular G6 instance, but with a higher CPU clock speed. There are also some special purpose x86 instances designed for special workloads. We have the SCC instances. These are designed for supercomputing clusters. You can use these to build supercomputing clusters for industrial simulation or genomics. They are essentially ordinary Alibaba Cloud servers, but they have RDMA-enabled remote direct memory access, and they have very, very high-speed convergent Ethernet connections, so they can be networked together through a very super fast network backbone. In fact, the SCC instances are actually a special purpose version of the EBM instances, which you can see on the right-hand side of the slide here. The EBM instances are what we call elastic bare metal. These instances have no virtualization layer. So these instances don't have a pre-built virtualization layer included on the machine. They are raw physical hardware. So if you want to run your own VMware stack, or you want to run OpenStack or ZStack or some virtualization solution, you can run that on these instances because there is no hypervisor running on these. It's just raw hardware. It's like buying your own server, but it's elastic. It can be provisioned within minutes, and it can integrate seamlessly with all of Alibaba Cloud's other products. So these EBM instances are a popular choice, say, for doing a direct migration of a VMware environment to the cloud, or for running certain application stacks that do not support virtualization, like, say, an Oracle database. We also then have heterogeneous computing ECS families. These are instances that include special purpose hardware for some particular task. So any instance with GN in the name will include a GPU. You can use the GPU either for machine learning tasks or for visualization, game streaming, maybe high-speed media transcoding. And then there's the F-class instances. These include an FPGA card. So if you have some purpose-built algorithm that you want to run on an FPGA card to do super fast processing, you can use the F-class instance. So what about these bare metal instances? I want to go back to bare metal because it's a very interesting and unique cloud product. So the advantages of bare metal are that you get the elasticity of a virtual machine. You can create or spin up a bare metal instance anytime you want. You get automated operations and maintenance because the bare metal instance incorporates itself into the rest of the Alibaba Cloud ecosystem. So you can use all of our monitoring and security tools. You can put this instance into a virtual network group just like you could with any of the ECS virtual machines. So it's a physical machine that has all the advantages of a regular ECS VM, and you get the advantages that only come with a physical machine. Zero functionality loss. If you need to use Intel VTX instructions, if you want to use Intel SGX, you can do that. You get zero performance loss because there's no virtualization overhead, and you get hardware level isolation. You are the only tenant on the machine, so you don't have to share with any other users. This table here just summarizes some of the advantages of the bare metal instance. Essentially, you get the advantages of a traditional physical machine plus a lot of the advantages of a virtual machine. So it takes these two sets of advantages, physical machine and virtual machine, and combines some of them. So here are the bare metal instance specifications. You'll notice that the bare metal instances are all very big machines. They're all very powerful. The smallest one is the 5th generation supercompute instance, which has 64 CPU cores. That's the smallest one. The others have 96 or 104 CPUs and up to 768 gigabytes of RAM, although that is upgradable to over a terabyte. If you work with our solutions team, they can give you more memory than that if you need it. And you'll notice that the bare metal instances can, if you need, be equipped with super high-speed convergent Ethernet interfaces or GPUs. Up to 8 V100 GPUs can be attached to a bare metal instance. So if you need ultimate performance, this is the way to get it. Here's a scenario where bare metal might come in handy. So again, because there's no virtualization, you can use the raw hardware directly. That means you can use special purpose functionality that's built into the Intel processor. So for instance, on newer Intel Xeon processors, there is the SGX extension, which allows you to create basically an encrypted, trusted execution environment at the chip level that lets you store your data and code in a trusted enclave, a private region of the computer's memory that's not readable by anybody else, not by the operating system, not by other applications. So if you are in fintech or banking or some other field with extremely high security requirements, being able to use SGX is a big advantage. Another scenario where bare metal is useful is re-virtualization. If you want to directly run a Docker container workload, so you don't want any virtualization between your Docker containers and the hardware, except for, of course, Docker itself, then you can run containers directly on a bare metal instance. If you want to install your own private cloud stack like ZStack or OpenStack, you can do that. If you want to use KVM yourself or install Microsoft's Hyper-V or use VMware directly, you can do that as well. All of that is possible on the bare metal instances. Another scenario is, of course, supercomputing. Our SCC instance class is a bare metal instance that just has a high-speed network interface. So if you're interested in building a supercompute cluster, bare metal is a good way to do that. And it's also a fast way to do that because you can provision the machines in just a few minutes. Then there's ECI. I include this here because it's something unique. ECI is a way to run containers without allocating servers on your own. So ECI is actually a component of the ECS service that lets you directly run containers without allocating individual ECS instances. And this actually works with our Alibaba Cloud Kubernetes service. So if you want to build a serverless Kubernetes cluster, you can tell Kubernetes to launch all of its containers using ECI, using the ECI engine, and then you don't have to manage your Kubernetes worker nodes because there are no worker nodes for you to manage. ECI takes care of it for you, so you get great elasticity that way, and you pay only for the actual deployments that are running on your K8s cluster. You don't have to worry about allocating and running your own ECS instances. One final thing here, instance failover. So how do we handle failures? So our uptime percentage for our instances for a single virtual machine is 99.975%. That's our monthly uptime. Also, if you do a multi-zone deployment, meaning you have instances across multiple zones in a region, then that can go up to 99.995%. These are the SLAs that we offer for a single region for either a single or multiple ECS instances. Again, that's 99.975%. or 99.995%, which is really, really high uptime. So the virtual machine service that ECS provides is extremely reliable. However, if 99.975% reliability isn't good enough, if you're worried about having an Alibaba Cloud zone fail, then what you want to do is deploy instances across multiple zones within the same region and build your architecture to have built-in failover, to have some fault tolerance. That way, if a zone does go down, you won't suffer. Within a single zone, if a single rack or a single server fails, that's no problem. We will actually live migrate your VM to another physical machine that's healthy. So within a single zone, you don't need to intervene at all to deal with hardware failures. We take care of that for you. However, if a full Alibaba Cloud zone were to fail, then you do need to have some plan to have a backup running for your service in another different zone. So how does billing work? Well, there's essentially 3 different modes. There's actually 4. We'll talk about the 4th one in a little bit. So there's pay as you go. You pay for compute capacity by the second. We bill you based on your hourly usage. So at the end of the month, we will present to you a bill based on how many hours of ECS compute time you used. And of course, the cost per hour depends on the ECS instance family and type that you select. Then there's subscription. This is a pay up front model. So a month or several months or a year in advance, you pay your fee for the ECS instance, and then the instance is yours for that period of time. So maybe I need a G6.xlarge, and I know that I'm going to need it for 6 months. Well, I can pay up front for the whole 6 months, and then for that 6-month period, the instance is reserved for me. The disadvantage of subscription is that you cannot delete the instance and start over, so you have to decide in advance what region and zone you want to use. The upshot, the plus, the advantage here is that the discount is up to 85% compared to pay-as-you-go pricing. So if you really do know that you're going to have stable long-term usage, subscription is a good, safe bet. Then there's the preemptible instance. Preemptible instances are a way for us to sell unused Alibaba Cloud computing capacity at a discount. These are basically pay-as-you-go instances that offer a very low pay-as-you-go rate that changes based on supply and demand. So basically we have an asking price, an amount per hour, which is lower than the normal pay-as-you-go price. You submit a bid. If your bid is greater than or equal to the asking price, then your instance starts. And we guarantee your instance will run for at least its first hour. But after that, if your bid price is no longer higher than our asking price, or if we run out of capacity for our regular PayG customers, then we can interrupt your workload and shut your instance down. So this is actually a great way to save money on batch processing, like processing logs or doing video transcoding in the background. Tasks that can easily be checkpointed and can be continued later are a great choice for preemptible instances because you get a big discount compared to regular pay-as-you-go. And most of the time, as long as your bid is high enough, your instance will continue to run. It's just when we run out of capacity or there's more demand for the preemptible instance service that our prices will increase. And when that happens, you can either choose to match our new asking price and keep your instance running, or let it shut down, whichever you prefer. But it is a good way to save money for batch workloads. Then there are reserved instances. So this is a cool model. This is sort of halfway between pure pay-as-you-go and subscription. So with a reserved instance, you buy something called an RI. You can think of it as being sort of like an ECS instance coupon. And that RI can apply either to a particular region and zone or just to a particular region, leaving you flexibility in which zone you choose. And the RI has 3 payment modes: no upfront, partial upfront, and full upfront, each of which offer different amounts of discount. Even with a 0 upfront payment, because you're committing to long-term usage, the RI offers you a discount over pay-as-you-go. So even if you pay nothing up front for your reserved instance RI, you still save some money over raw pay-as-you-go, and you get, therefore, some of the advantages of the subscription. But unlike a traditional subscription, you can, if you want, delete your instance and create a new one, which gives you more flexibility in how you provision your instances. So it's still on demand, like pay-as-you-go, but with some of the cost benefits of a subscription model. Okay, let's move on to ECS storage. Alright, so ECS utilizes Cloud Disk as both its system and data disk. So ECS instances will use this Cloud Disk service both for data disks and for system disks, which are used to boot up ECS instances. So the Cloud Disk itself is actually not a physical disk installed on the same physical server as the virtual machine. It is instead an abstraction provided by our Pangu storage service. So the entire Alibaba Cloud system runs on top of Apsara, and Apsara has a component called Pangu that is used for handling storage interactions. So the nice thing about this is that each cloud disk relies on Pangu for reliability and redundancy. So each Pangu cloud disk is actually stored 3 times separately on different physical servers attached to different network switches, i.e. not in the same rack, which means that any 2 of these physical servers can fail and your cloud disk will still continue to work. So you get extremely high reliability this way. I believe the data durability for the cloud disk system is 11 or 12 nines, so it's very high. You can also flexibly mount and unmount cloud disks and move them between ECS instances. There are currently 3 types: UltraDisk, which is a standard rotating hard drive; standard SSD, which is a solid-state drive; and then enhanced SSD, which is a high-performance solid-state drive. So the cloud disk itself can be purchased independently of the ECS instance. They can be mounted to any ECS instance, assuming that the instance is in the same zone as the cloud disk. So that's important. The cloud disk has to be in the same zone as the ECS instance it's attached to. It cannot cross zones, and that's for reasons of network bandwidth and latency, because again, remember, each zone within a region is its own physically independent data center, and those data centers are networked together using Alibaba Cloud's private links. But because it's a network link between 2 physical buildings that are not near each other, there is some delay. So it's a little bit too slow to run a disk service. So ECS instances and their cloud disks need to be together in the same data center, meaning they need to be in the same zone. And just like a real physical block device installed in a real server, only one ECS instance can mount a cloud disk at a time. If you want to have another ECS instance mount the disk, you have to unmount it from instance A first, and then mount it again on instance B. Disks are billed based on their type, so UltraDisk, standard SSD, enhanced SSD, and also based on their capacity, which is their size in gigabytes. And just like with ECS, there are pay-as-you-go and subscription billing methods available. You can see here on the bottom of the slide we have an example. We have a disk, we'll call him D0001, that's mounted to an instance I001 in zone A. If you want to move this disk over to I002, what you would have to do is from instance 001, you would unmount the disk. So you'd do that at the operating system level. So you'd log into the instance and unmount the disk. Then from the Alibaba Cloud Console, you'd detach the disk from instance 001, attach it to instance 002, and then you'd log into instance 002, and again from the operating system level, mount the disk. And again, that would only work if these two instances are in the same zone as the disk. So how do you choose a type? Well, it has to do with how much performance you expect and also the cost per gigabyte that you're trying to achieve here. So UltraDisk is of course the cheapest type, but it's also fairly slow compared to the other disk types. It has a maximum throughput of 140 megabytes per second and a maximum IOPS of 5,000. In fact, newer instances such as the Generation 6 don't even support UltraDisk, so this is only something you can use with older instance classes. Standard SSD is a lot faster. It has 5 times the IOP performance, so it's got 25,000 IOPS with a maximum throughput of 300 megabytes per second. And then enhanced SSD originally had just 3 types, but there's now a 4th type not listed here called PL0. So here you can see we have PL1, PL2, and PL3. There's now a new type called PL0. And on our most brand new ECS instances, the Gen 6 Enhanced, so we call those 6E. On the 6E instances, actually you can't use UltraDisk or standard SSD, you have to use enhanced SSD PL0, which is faster than standard SSD but a lot cheaper than the other 3 enhanced SSD types. So how do you choose between those? PL0 is a good safe default if you're using one of our new Gen 6 enhanced instances. PL1, PL2, and PL3 are distinguished mostly based on their maximum IOPS and maximum throughput. So you choose whichever one meets your workload. For instance, you might use PL3 to run maybe a database or a file system like HDFS, whereas PL1 would be fine for a system disk. One of the nice things about having cloud disks be a virtual disk service rather than an actual physical disk attached to the server that holds your VM is that you can do things like take snapshots. So an ECS snapshot is a copy of all the data on a cloud disk, and you can take a snapshot from a disk that's running and mounted on an instance anytime you want, and you can set up automatic policies to do snapshots for you. So let's say that you want to make a complete backup of your ECS instance's boot disk, the system disk, every day at 3 a.m. and you want to keep those backups for 14 days. Well, you can create a policy to do that, and then every day at 3 a.m. a complete backup of your disk will be made and stored separately from the disk itself, and you can restore from that backup anytime you want. So that's great for routine backup. It's also great for creating new instances. So if you spend time to set up an ECS instance the way you want, and then you want to clone or copy that instance, you can use one of these disk snapshots to do that. Disk snapshots are also a great way to clone the data on a disk. So if you're trying to do testing or development and you want to poke around on the disk without affecting a running system, you can take a snapshot and then mount that snapshot to another ECS instance in your test environment and do all of your checking and probing and analysis over there without affecting your live system. Again, disk snapshots, there's 2 kinds. There's manual snapshots and then there's automatic snapshots. Manual snapshots you can make yourself from the console anytime. Automatic snapshots, you have to define a snapshot policy, and then that policy will determine when snapshots are made and how long they are retained for. You can have up to 100 automatic snapshot policies in a given region, and of course more than one ECS instance can use the same policy. It's generally a good idea, by the way, to avoid making snapshots during the peak use time for your instance, because there is a performance hit, especially when you make your first snapshot, which has to clone the entire disk. Okay, in terms of limitations, you can create up to 256 manual snapshots per disk and up to 1,000 automatic snapshots per disk. And snapshot fees are charged based on how long you keep the snapshot and how much space it takes up. But I should say the fees for snapshots are much, much lower than the fees for cloud disks themselves. So you can safely keep quite a lot of snapshots without incurring too much expense. But still, when you create an automatic snapshot policy, it's a good idea to include in the policy a rule about when to delete old snapshots. The snapshots are made using an incremental mechanism. So after you make your first snapshot, when you next create a snapshot, when you create your second snapshot, only changes between your first snapshot and the cloud disk are going to be kept. So if you have a 100 gigabyte cloud disk, your first snapshot is going to take up 100 gigabytes. It will be a copy of everything on the disk. But let's say maybe a day goes by, and of those 100 gigabytes on your cloud disk, only about 2 gigabytes worth of data has actually changed. Well, great. When you go to do your second snapshot, only those 2 gigabytes that are different from your first snapshot will be stored. So the second snapshot will happen faster, and it will take up less space, and it will cost less, because it only records changes between the previous snapshot and the current state of your disk. And the changes, the increments between snapshots, Alibaba Cloud Snapshot Service takes care of recording those for you, so you can delete any snapshot in the chain and restore from any snapshot in the chain without worrying about missing any data. The relationship between the snapshots themselves and between your cloud disk is all recorded and managed automatically by our system. You can also turn snapshots into what we call a disk image. A disk image is just a special snapshot that you can boot from. So it's a snapshot you can use to start your instance. So let's say that you have installed Apache and MySQL and maybe a vanilla WordPress theme on an ECS instance on the system disk along with the operating system. Well, what you can do is you can take a snapshot of that disk. You can then, from the console, convert that disk into what we call an image, and then next time you go to the buy page for ECS, or the next time you create an ECS from the console, you'll have the option to select what we call a user-defined image or custom image. And in that custom image list will be this image you created that has Ubuntu plus WordPress on it. And then you can just boot a new ECS instance directly from that. You can also take those custom images and share them with other users. So if you have multiple Alibaba Cloud accounts, you can share an image from one account to another. And this isn't just limited to you. Our partners and marketplace builders can also use this image feature. So when you go in the Alibaba Cloud Marketplace, the software you see there is available in the form of a disk image. So when you buy third-party software from our cloud marketplace, it's in the form of a disk image. And of course, you yourself, if you register, can become a marketplace vendor, and you can take your custom images and sell them in the Alibaba Cloud Marketplace. Of course, you don't have to do any of that. When you use ECS for the first time, you can use what we call public images or system images. These are just disk images that we prepare ourselves. So these come from Alibaba Cloud, and this includes multiple versions of Linux and Windows and even FreeBSD. So you have a lot of choice when you're starting out for what you want your base image to be, because we provide a set of public images. But keep in mind that if you need it, you can create a disk snapshot yourself and turn it into a bootable disk image that you can use to create new ECS instances. The obvious benefit of creating a disk image is that after you purchase an ECS instance, you can do all the configuration you want to get your application up and running, and then you can, in the future, make clones of that instance that you've already set up correctly, and you'll avoid doing all that manual work to install software packages again. Same thing for the marketplace. The images in the Alibaba Cloud Marketplace are already pre-configured and ready to use. So if you need something like WordPress or Fortinet Firewall already pre-installed, you can get that from our marketplace in the form of a disk image. Alright, now we come to ECS networking. How do you connect ECS instances together? How do you connect them to the internet? Well, the key component in ECS networking is what we call the Virtual Private Cloud, or VPC. A VPC group is a private network IP address range that hosts one or more ECS instances. VPC groups are completely isolated from one another, both within a single user's account and between different users' accounts. So each VPC is its own little island. The instances within the VPC can talk to each other and can also potentially talk to the internet, but they are disconnected from other VPCs unless you explicitly peer those VPCs together. So unless you make changes to your VPC to connect it to other VPCs, then it remains completely private. Within each VPC, there is a vRouter, or virtual router, which is used to route traffic around inside the VPC and also to route traffic to and from the internet. And then there will be one or more vSwitches. You can think of each vSwitch as representing a subnet. So within the VPC's IP address range, each vSwitch will have its own subnet range. So for instance, if your VPC network is the 192.168.0.0/24 IP address range, then maybe your vSwitches could each be a /26 within that /24 network block. Also, within the VPC, there's the concept of a security group. This is basically a set of stateful firewall rules that apply to your ECS instances within the VPC. You can have multiple security groups within a VPC, and these security groups are used to enable the ECS instances to safely talk to other networks, say the public internet. Then there's also what we call elastic IPs. You can attach these to your ECS instances to grant them access to the public internet. An elastic IP is just an IPv4 public internet facing address. And the nice thing about EIPs is that they can move between different ECS instances. So you can flexibly move EIPs between different instances, even instances that are not in the same zone. And that's another core concept of the VPC. ECS instances and ECS disks live in a particular zone. So maybe Singapore Zone A. So if your instance is in Singapore Zone A, you cannot move it to another zone. It can't be migrated to another zone. Same thing for disks. But the elastic IP, he can move between zones. So the elastic IP can move between zones, and a VPC group can include ECS instances that live in different zones. So it's totally fine for a VPC in the Singapore region to include ECS instances from zones A, B, and C. That would be all right. How do security groups work? Well, it's just a firewall, essentially. Security group rules either allow or deny traffic to an ECS instance. So a security group rule would include the following information: the action or rule type, so is this an accept rule or a block rule, the port range that the rule applies to, maybe port 80 up to port 90, or maybe just a single port like port 443, the protocol, so what type of traffic does the rule apply to, TCP, UDP, or ICMP are all supported, and then the authorization objects, so what is it that I'm trying to accept or block? From which IP address range do I want to accept or block this traffic? You can either specify a single IP address, an IP address range in the form of a CIDR block, or a security group ID of another Alibaba Cloud security group. So you can specify an ID for another security group and then allow or deny traffic from that group into your security group. Security groups are a regional concept. Just like a VPC, the security group can span multiple zones within a region. Each security group can contain multiple ECS instances, either in the same zone or in different zones. Each ECS instance you create has to belong to at least one security group. It can belong to more than one if you want, but it has to belong to at least one. And by default, ECS instances in the same security group can communicate freely with one another. By default, instances in different security groups cannot communicate with each other. Keep that in mind. So if two ECS instances are in the same security group, they can communicate freely with one another no matter what the security group rules are. But if they're in different security groups and they want to communicate, you have to create rules to allow cross-security group traffic between these two groups. And at the bottom of the slide here, there's an example of the rules that are applied when an incoming connection tries to reach an ECS instance. So let's say on my machine I'm running Xshell or another terminal. I try to SSH into my machine on port 22. What will happen is the security group will intercept that connection. It will see that there is an inbound TCP connection request on port 22 to my instance. It will check the rule table and it will see, okay, I have a rule that allows traffic on port 22 from any public IP address. Great, I will now connect you. Or it will find a deny rule and it will drop the traffic without sending any response. So those are the two things that can happen. Either it looks at the protocol, source IP, and port number and determines that the traffic is allowed and passes it through, or it determines that the traffic is not allowed and drops it. How does the VPC communicate with the internet? There's actually multiple ways that this can happen. Before we mentioned the elastic IP, but that is not the only way. You can also assign a public IP address directly to the ECS instance. This is different than the elastic IP because the public IP that's bound to the instance cannot be removed. So a generic Alibaba Cloud public IP that's attached to an ECS lives and dies with that ECS instance. There's no way to take that IP and assign it to another instance later. Only Elastic IP allows that. A standard public IP does not. Elastic IP is the other way to give ECS instances inside your VPC access to the public internet. Unlike the traditional Alibaba Cloud public IP, the Elastic IP can be moved between different ECS instances. You can move it later if you want. And of course, it's billed separately and purchased separately from ECS in order to enable you to move it around. You can also create and configure a NAT gateway. VPC groups support creating a NAT gateway, and you can configure both SNAT and DNAT rules for the NAT gateway to allow traffic in and out of your VPC group without giving your ECS instances their own public IPs. And then for inbound traffic only, you can use a server load balancer. So if the ECS instances in your VPC are maybe serving a web application, then you can put a server load balancer into the VPC, give the server load balancer a public IP, and then all the incoming traffic will go to the SLB first and will then be distributed out to your ECS instances over the VPC private network. This way, the ECS instances do not need to have their own public IP. They can rely on the server load balancer's public IP instead. So an Elastic IP, again, is just a public IP address resource that is independent from ECS and can be moved around. In fact, it's not limited to ECS. You can also take an EIP and bind it to a NAT gateway or to a server load balancer. This is great because it means that even if your application starts small with a single ECS instance, later if you want to scale up and start using a load balancer, you can do that without needing to get a new public IP. You can just take your existing EIP, remove it from your old ECS instance, and then put it on your server load balancer. EIPs are also great if you later on need to upgrade your backend ECS instance, because you can leave your current instance in place serving requests through the EIP. Then you can set up a newer, higher specification ECS on the side in the same VPC, but to the side and not serving traffic. And then once that instance is set up, you can move the EIP from your old instance to the new one and then delete the old one. So this is the EIP gives you a lot of extra flexibility. If you compare EIP versus standard public IP, you'll find that this is the major advantage. So EIPs are purchased separately from ECS, and they can be reattached to NAT gateways, load balancers, or other ECS instances whenever you want. So the advantage is flexibility. Public IP doesn't offer that flexibility, but it is slightly cheaper. So public IPs attached permanently to an ECS are cheaper than elastic IP addresses, but lack the same level of flexibility. Then there is the concept of an ENI. This is a virtual network interface that can be attached to an ECS instance. All Alibaba Cloud ECS instances have at least one ENI that's used to attach to the VPC private network. So if you want, you can attach multiple ENIs to a single ECS instance to achieve low-cost failover or deploy high-availability applications, or maybe set up your own firewall or do other fine-grained network management. Different instance types support different numbers of ENIs. The larger instance types will support sometimes up to 32 network interfaces on a single ECS instance, but most instance types will support at least 2 ENIs. An account can have no more than 100 Elastic Network interfaces in a single region, so keep that in mind. And an ECS instance must be in the same zone and region as the ENI you're binding to it. So the ENI, you can think of it as being a flexible private network interface. The EIP is a flexible public network interface. All right, so now we turn our attention to and user data. So instance metadata is provided via a HTTP service that's actually accessible from any Alibaba Cloud VPC, regardless of whether or not your ECS instance has a public IP address. The URL for that service is, as shown here at the top of the slide, 100.100.100.200/latest/metadata. Essentially, you can use this data to do things like automate some of the setup and configuration of your instance. Just to give an example, maybe you have a setup script that you bake into your instance boot disk image, the disk image, and this setup script needs to know your instance's hostname and public IP address. Well, it can get that information from the metadata service and then use that to configure other things like WordPress or Apache. And then there is the user data. So the user data is input information that the instance uses for automated bootstrapping at instance creation time. Again, there's an internal endpoint for that, 100.100.100.200/latest/user data. And of course, you can find the content of that user data via wget or curl on Linux or via PowerShell's invoke REST method on Windows if you're curious to see what's in there. Any instance, when it first boots up, will query this service and will execute whatever items it finds in the user data field. So it could be a shell script, a Linux shell script, starting with #bin/bin/sh, or it could be a Windows batch or PowerShell script. And these are essentially just scripts you use to do initial setup when an instance first boots up. Those would be located in this user data field. And that's all for additional settings. Now let's have a full end-to-end demo of ECS. So we'll start from the AlibabaCloud.com homepage. In the upper right-hand corner, we'll click on the console link to enter the console. From the console homepage, we'll navigate over to the ECS service and we'll try creating our very first ECS instance. So I'll click on the orange menu button here. That will cause a pop-up menu to open from the left-hand side of the screen. I'll mouse over products and services. That will also open up a drop-down menu. From here I can search for products or pick them from the overall product list. This includes all the products. I can also sort by category. In my case, I want to find ECS. So I'll type ECS, and you can see at the top of the search results down here is Elastic Compute Service. These items up here are not from the search results. These are just pages I have recently visited. So under Elastic Computing, I'll click on Elastic Compute Service to go over to the ECS console. Now from here, this is the home page. I can see information about all of my instances. There's also a search page from which I can search for a particular instance or group of instances based on a keyword or a tag. I will click on Instances to go to my instance list. The Instances page lists all the instances in a given region. So when I move from the Overview page to Instances, you'll now see that there is a region drop-down. And I'm currently in Singapore. So let's now go ahead and create an instance for ourselves. I'll click on the Create Instance button up here in the upper right-hand corner. That will open a new tab. And from here I can choose the instance type, billing method, and region. So I'll choose pay-as-you-go rather than subscription or preemptible. I will choose pay-as-you-go because, of course, I plan to delete this instance once the demo is over. For the region, we'll choose Singapore. And Singapore has 3 zones, Zone A, Zone B, and Zone C. You can pick a particular zone, or you can click on the random button to be allocated a random zone. The instance type, you can see here that we offer both bare metal, heterogeneous, which is GPU and FPGA, and our x86 types. And then within each of these type families, there are subcategories. So in the case of x86, we have general purpose, that's the G type, compute, that's the C type, memory, that's the R type, and so on. In my case, I plan to choose an ECS.G6E.extra large, which has 4 vCPUs and 16 gigabytes of RAM for a 1:4 CPU to memory ratio as mentioned. And I just need to wait for the instance selection to load. Then I can switch this radio button to the G6E.X large. Let's give that a moment to load up. I can now select the G6E.X large. Great. I want 1 unit. I'm going to be buying 1 ECS instance, although I could create up to 128 at a time. For my disk image, I will choose Ubuntu. You can see here there's a wide variety of choices. Multiple Linux distributions are supported, including even FreeBSD. So if you want to use something that's not Linux or Windows, FreeBSD is an option. So let's go ahead and choose Ubuntu in this case. You can also see if someone else has shared an image with your account, you can use shared images. If you've created your own images, you can use a custom image, or you can pull an image from the marketplace. If I were to click that, that would take me over to the marketplace where I could choose a pre-built image. In my case, I'm just going to stick with Ubuntu 20. And I'll turn on security hardening. What that does is it installs the Alibaba Cloud Security Center tools, which will do things like detect brute force password cracking attempts and some types of backdoors and Trojans. I'll leave that turned on. Disk, because I chose a G6 Enhanced, I can only choose Enhanced SSD. So because of the instance type that I chose, I'm limited to just the fastest eSSD type. I could also attach a NAS file system, a network file system, or add up to 16 additional data disks. I won't do that. I will leave the default settings here. My system disk can be up to 500 gigabytes, but any data disks I add can be up to 32 terabytes in size. In my case, I'll leave it at the default 40 gigabytes, and I can choose either PL0 or PL1 as the eSSD storage type for my disk. I'll choose the PL0 type, which is the most affordable. It has the best price-performance ratio per gigabyte. I can also set up automatic snapshots from here, from the checkout page, which will back up my instance on a regular schedule. The default policy is once a day at 1 a.m. and the backups are kept for a week. I could also click here to create a custom policy. Let's choose the default policy and we'll back up all disks. In my case, there's only 1 disk to back up. Once I've confirmed that all my settings are correct, I can move on to networking. So let's go ahead and move on to the networking configuration. My network type, it will be VPC. My network type is always VPC for new instances. I need to have a VPC group already created and a vSwitch already created. If I don't have that, then the Alibaba Cloud Console will automatically put my instance into the default VPC, which is a VPC that is automatically created by Alibaba Cloud. If I want, I can go create a VPC right now. So let's do that. So I'll click on Go to the VPC console, and that will open another tab, and I can go ahead and create my own VPC, just so you can see what that process is like. So I'll click on Create VPC. I have to give my VPC a name. I'll go with Singapore VPC, and then I can choose one of the 3 default CIDR blocks, all of which are RFC 1918 private network blocks, or I can choose a custom CIDR block, which will have to be a subnet of one of these 3 blocks. It can't be a different IP address range than these 3. It has to be a subnet of one of these 3. In my case, I'll stick with default CIDR block and I'll choose this /16. That's big enough for me. I can add a description if I want. I can group resources together in the console into resource groups. In my case, I'll leave this selection here, which is the default resource group. Resource groups are just a convenient way to group Alibaba Cloud resources together per project or per RAM user. Okay, so now I need to create some vSwitches. Remember, each VPC group has to have 1 or more vSwitches, which are subnets of the VPC group's IP address range. In this case, this /16 range here. So I'll create 3 vSwitches, one for each zone in the Singapore region. And I'll name them so that I remember which zone they are in. So I'll call this one vSwitch Zone A, and I'll choose Singapore Zone A, and I'll choose a /24 subnet of my /16 up here. Then I will click the Add button to create another vSwitch, which I'll call VSW Zone B. I'll choose Zone B, and now I have to choose a non-overlapping subnet. So I'll put a 1 here. So now I have 192.168.0.0 and 192.168.1.0 as my subnets. Let's add one more. Let's add one for Zone 3. And from the Create VPC console here, you can only add 3 subnets, 3 vSwitches. However, if you go into the VPC console itself, the vSwitch list here, then you can create as many as you want. Luckily for me, 3 is enough because Singapore has exactly 3 zones. So I'll go vSwitch Zone C, and again I need a non-overlapping subnet. Great, okay, so I've done that. I click OK, and that should create my VPC and those 3 vSwitches for me. And it worked, it's done. So now I hit complete, and I now have a Singapore VPC group. So if I close this console, if I were to close this console and go back to the buy page and hit refresh, I would now be able to select the Singapore VPC. And of course I can also, if I want, select a vSwitch. Maybe let's choose the Zone A vSwitch, which will cause my instance to be created in Zone A. Let's say that I want to access the internet, so I could check this box here to create a public IP address with a bandwidth up to 100 megabits per second or down to 1 megabit per second. In my case, I'm not going to assign a public IP address now because I want to show you how to use an elastic IP. So let's uncheck that box. This instance will not be given a public IP. Let's do 2 more things from the VPC console. So my instance is going to need an elastic IP, so let's go buy one. I'll click on elastic IP, and then I'll click on create, and we'll buy ourselves an elastic IP, also pay as you go, in the Singapore region. So I need to find Singapore in my list. I will choose a bandwidth of 200 megabits per second. EIPs have a higher maximum bandwidth than traditional public IPs that you bind to an instance. And then I'll click Buy Now. So now I have an elastic IP. Well, I don't have it yet. I need to check out. I actually have to agree to the terms of service. Then I click Activate, and now I have an elastic IP address. And elastic IPs are billed hourly. So in my case, I'm paying 0.6 of a cent per hour. That's US dollars, USD. I now have my EIP created. And while we're in the VPC console, maybe we can refresh and double check that that's there. And sure enough, it is. It's ready to go. And I'll be able to attach it to an ECS instance later. This is the public IP address that I have just purchased. I now need a security group. Remember, every instance must be a member of one security group. I can either have the system create a security group for me with some simple default rules, like say to allow port 22 or port 80. I can check and uncheck these boxes to decide what traffic is allowed in, or I can click Create a Security Group to go create my own custom rules. So maybe let's do that. I'll click on Create a Security Group, and that will take me over to the Security Group portion of the ECS console. That's down here under Network and Security at the top. That's where security groups can be found in the ECS console. And I'll click on Create Security Group, and we'll make a new one, and I'll call it Singapore Web SG. And I'll say this is my web server security group. And the description is optional, but it helps you remember what the group is for. There are 2 types of security groups, basic and advanced. If you click on this info button here, if you mouse over that, over the little blue eye, you'll see that basic groups are just simple stateful virtual firewalls to put in front of your ECS instances, whereas advanced groups are sort of super high security groups that are designed for enterprises. They have much stricter deny all security policy associated with them. I don't need that, so in my case I will choose basic security group, and I want to attach it to my Singapore VPC, so I choose that from the VPC dropdown. These are the default rules for the Web Server Linux group type, which is the template I chose. Let's go with those rules for now, and we'll change them a little bit in a moment. So I'll click OK, and then I'll click on Create Rules. That will take me over to the inbound and outbound rule settings. Currently we allow all outbound traffic by default, so I don't need to add any rules there. we're just allowing everything out, and we allow ping, SSH, HTTPS, and HTTP in. What I'm going to do in the demo today will not require HTTPS, so I'll go ahead and delete that rule. I'll click OK. Now I only have 3 rules, one to allow ping or ICMP traffic, one to allow SSH traffic, and one to allow web traffic on port 80 from any IP address, so from anywhere. And now my security group is also ready to go. I can now close the VPC console and the security group page in the ECS console and go back to the buy page. And here I can click on Reselect Security Group to select my Singapore Web SG. I'll do that, and then I'll click Select. Now I have selected a security group for my instance. This is where I configure my Elastic Network Interfaces, or ENIs. I can choose whether or not to release them with the instance and whether or not to auto-assign an IP. Your first ENI, and every ECS has at least one, doesn't allow you to adjust these settings. The instance must have an IP address on its first ENI, and the ENI must be released with the instance. But if I add additional ENIs, then sometimes I'm able to adjust these settings. Let's not do that though. One ENI is enough. And if you want, you can enable IPv6 on some instances in some Alibaba Cloud regions. So I'll click on Next to go over to System Configurations. So from here, I set up my host name, I set up a human readable name for my instance, and then I can set up a key pair or a password. So let's do all of that. I will not use an SSH key pair for the demo. I will simply use a password. So let me go ahead and choose a simple password here and just type it directly in. And that's how we'll log into the instance. In production, you should not do that. So in production, you should definitely use an SSH key pair. But when you're in a testing environment, you might be able to get away with using a password that you come up with yourself. Excuse me a moment, I have to wait for the page to reload. There we go. And then we'll confirm our password. So I'll click on the Confirm Password dialog. And then once we've put in our new confirmed password, once we've double-checked that it is correct, then we can move on to naming our instance. Whoops. Sorry, the drop-down menus here for auto-choosing a password from my Chrome autocomplete history are getting in the way of my typing. Give me just a moment to finish typing this all in. Okay, so we were able to set a password. Let's now go ahead and give this instance a name. I'll just call it Web Server SG. So it's my web server in Singapore, so I'll call it Web Server SG, and then we'll choose a similar host name so that when I'm logged into the instance, I remember which one it is. Typically, this is better than using the generic host name, which is going to be the instance's Alibaba Cloud ID number, which is not very memorable. So we'll choose an instance name, and then we'll choose a host name that matches the instance name. They don't have to match. I just find it convenient. That way when I'm switching between the terminal and the console, I know which is which. So let me type in the host name, Web Server SG. And then there's a few settings down here. You can add a sequential suffix to the end of each instance's name and host name. That way if you're creating instances in a group or batch, they don't all end up with identical names. So if I were to check that box, then this would be Web Server SG1, and the next instance created would be Web Server SG2, and so on. It's also possible to check this box at the bottom here to turn on what we call release protection. If you turn on release protection, then you will not be able to accidentally delete the instance from the instance overview page in the ECS console. If you try to delete it from there by clicking the release button, you'll receive an error or warning message, and you'll have to go into the instance settings and disable release protection first before you're able to delete. So that's just a safety feature. There's also this advanced setting here under at the very bottom. If I click on Show, I can assign what's called a RAM role to this instance, and I can paste in some user data. So if I wanted, I could write a script here. So for instance, I could do something like, I could write a small shell script and then paste it in here to do something like create a web server for me. So maybe I'd run some commands to fetch Ubuntu package updates and then install Nginx or Apache 2. I'll skip that though. I don't need to assign a RAM role or set up any user data, so we can just move on to the next section, grouping. So I'll click on grouping, and that will take me over to the grouping page. So this has nothing to do with the configuration of the single ECS instance itself. This is where I can do things like determine which resource group or deployment set the instance should be in, or how it should be tagged. So this is just to help me keep track of the instance, especially if I have multiple instances. It's a good idea to tag the instance based on which team is paying for it, or maybe what project it's part of, or what environment it's part of, dev, staging, or test. I can keep track of that by using tags. I won't add any tags for this demo, but you can add up to 20 tags from this page. And then resource group. Let me show you what a resource group is. So a resource group is a container or set of resources within an Alibaba Cloud account. Again, the resource group is just a way to group resources together to better manage and keep track of them. A deployment set is a way to make sure that the instances are running on or near the same, or are assigned to different physical servers. So actually the deployment set's role is to make sure that your instances don't end up on the same physical server in the Alibaba Cloud Data Center to avoid hardware failure. So this is a way to get even more reliability for your instances within the same zone. If you put them in a deployment set, they'll be scheduled so that they're not all running on the same physical machine. If you have a dedicated host, which is a special dedicated physical server that you have purchased, you can make sure your ECS instances all get launched together on that physical host from the dedicated host settings here, which is a great way to ensure that your VMs are in an isolated environment separate from other customers, and it also ensures very high intercommunication performance between those ECS instances. And then you can also create what's called a private pool, but we won't go into detail about that in this class. You can just know that you have this feature available. I'll click on preview to move on to the preview page. From the preview page, we can double check our billing method, the number of instances we'll be purchasing, the region, the image, which is the operating system type and version. We can see the instance type is a enhanced general purpose generation 6, 4 vCPU cores, 16 gigabytes of RAM, and we can see that the system disk is an enhanced SSD, 40 gigabytes in size, and it has automatic daily snapshotting turned on. I can see the network type is VPC. I can see which VPC and vSwitch the instance will be attached to, and which security group or security groups it is attached to. And then I can see the login type, which is password, the instance name, and the instance host name. If I wanted, I could then save all of this instance configuration I've done as a launch template, which I can then use to create other instances, or as a ROS template, which can be again used to create a resource stack just like this one, to clone the entire configuration. And if I click View Open API, I can see what API call I would have to make in Java or Python or other languages in order to create this instance programmatically. There's also the option to turn on automatic release. This will delete the instance automatically after a given period of time has passed. I will turn that on just in case I forget to delete this instance after the demo. Finally, I agree to the terms of service, and then I click Create Instance to go ahead and start my instance running. So now that I've clicked that, I can actually close this tab and go back to the ECS instances list for Singapore inside the ECS console. And if I click Refresh, I can now see that I have an instance starting up. So now might be a good time to attach our Elastic IP to this instance so that once it boots up, I can access it via SSH over the internet. So I'll go down to Network and Security, and there are two hyperlinks here, one to the VPC console and one directly to EIPs within the VPC console. I'll choose that one. That will open up a new tab, which is just a shortcut to the VPC console itself. And here's the Elastic IP address section. I can see my EIP, and then I can bind this EIP to some other service. So let's check the box next to our EIP, and let's go ahead and attach it to something. Actually, first I need to release it. It looks like it might be attached to something right now. So we'll go ahead and release it. I shouldn't have done that. I should have clicked on bind, excuse me. That's okay, that just means we need to buy another EIP. So I'll just go back and buy the EIP again. It was pay as you go, so I can easily replicate those steps. Again, we'll choose a 200 megabit per second bandwidth, and then I'll buy and activate just like I did before. Our release will actually delete the elastic IP, so I should not have done that. Unbind is what you do to remove an elastic IP from an ECS instance. Release will actually delete the elastic IP, so do be careful with those buttons in the console. Otherwise, you might do what I did and accidentally delete your elastic IP. And of course, once you did that, there's no way to get it back. Okay, I'll refresh. Here is my EIP. Great. I want to go here and click on More. Actually, let's double click on the EIP itself. Go to the EIP list and then click on Bind Resource. I want to attach the EIP to something. So you can see again, how did I do that? From the EIP section in the VPC console, I clicked on the elastic IP's ID number, and I went to Bind Resource. And I can choose to attach it to a secondary ENI on an Alibaba Cloud instance, an ECS instance itself, a server load balancer, or a NAT gateway. I will choose ECS instance. We'll use a normal binding, and I will choose this instance that I just created, Web Server ST, and then I'll click OK. And now the elastic IP is bound to that ECS instance. So if I go back into the ECS console and I refresh, I should now see two IP addresses here. One is the private internal IP within the VPC group, and one is that elastic IP that I just. So let's go ahead and copy that to the clipboard, and I'll start up a console. And we'll go ahead and log into that instance using our password. Let's see what happens. Whoops, I typed the password wrong. Let's try again. Okay, we're now logged in. And because we have an internet connection, I can do things like run apt update. So let's go ahead and run an update and then install Apache. And then we'll see if we can access this instance over port 80. So I'll install Apache 2. I'll say yes. Once it's installed, we'll make ourselves a little website, and then we'll try accessing that website from Chrome over the internet. Okay, so Apache's installed. We need to enable it, so if the instance reboots, it will continue running. And then we can go to var www.html, and we can make a new index.html. We'll delete the test page, and we'll make our own. So I'll use Vim to set myself up a new page. So we'll do something simple because I need to do it from memory, so I'm not going to get too fancy here. I'll just do something very simple. I'll make a page that says, "Welcome to Alibaba Cloud," and then I will go ahead and save that. And now if I were to copy this IP address again and open a new tab, whoops, I should be able to go over there. And sure enough, it loads right away and it says, "Welcome to Alibaba Cloud." So we can see that it is working and serving requests on port 80. Now our security group rules also allow us to send ICMP traffic, so we should be able to ping this instance too. So let's take a look at our security group rules here. Here they are. Let's try to ping the instance. So I'll log out and we'll try to ping this IP address and we'll see what happens. And you can see it's working. And now let's see something neat. So I'll leave this ping running in the background and we'll come back to it in a moment. I'm going to delete this rule. So I'll delete the rule that allows ICMP traffic. Now we only allow port 80 and port 22. And sure enough, you can see that our ping has started to fail. The security group is not allowing this traffic through. It's dropping it, so we're getting request timeouts. If I add the rule back in, again, leaving the ping running in the background, then we should once again start seeing that ping succeed. So again, I'll allow traffic from anywhere, and I'll click OK. And now I've added the rule back in. If I go back to my console, after a few moments, we can see that once again, ping is starting to succeed. So the security group does cause an almost immediate effect. It takes effect in near real time. Okay, we'll stop the ping. And now we finished testing out our security group. So another thing we can do is take snapshots. So let's make a copy of our ECS instance. In fact, just to see what will happen, let's go ahead and make a snapshot of our ECS instance and then unbind our elastic IP, create a new instance, boot from the snapshot and bind the Elastic IP to the new instance. This will be effectively migrating everything. And what we'll do is we'll actually move our instance into zone B, just to sort of simulate migrating to another zone. So I need to take a snapshot of my instance. So I can click on the instance ID. Let me do that again so you can see it. I click on the instance ID from the instances list. I go to disks, and from here there is a create snapshot button next to each of my disks. In my case, I only have one. I'll click on create snapshot and I'll call it web server SG, and I'll put in a date so that I remember when this was created, and I'll click on create, and now the snapshot creation process has started. If I go over here to snapshots, I can actually see that this has started, and now we just need to wait a few moments for it to finish. Because this is the first snapshot, we do need to make a full copy of the disk, so this could take a little while because we need to copy all 40 gigabytes. Alright, so after patiently waiting about 5 minutes, the snapshot is done. We're not quite done though, because now we need to create an image. So a snapshot is a backup that you can use to restore back onto the disk that created the snapshot. But if you want to use the snapshot to create or boot new ECS instances, you have to first convert it into a custom image. So there's a button here, Create Custom Image, that does just that. So I'll click on Create Custom Image, and now I'm going to create a bootable image from this snapshot, which I'll call, I don't know, Web Server Golden Image. And again, I'll put a date on here so I remember when I did this. Apache 2 plus static website application code, HTML, for my site. And again, I can choose a resource group and I can add some tags, but I won't. I'm just going to use this one image. And actually, if you want, your images can include data disk snapshots of other disks. I'm not going to do that, but if you had a ECS configured in a way where, in addition to the system disk that you boot from, you also wanted to be able to pull in some data when you created new instances, you could add data disk snapshots down here that included that data. I won't do that. I will just click Create to create my system disk custom image. And now that's done. And if I were to go back to the ECS console page, I can go down to Images under the Instances and Images menu, and sure enough, here is the image I just created. Creating an image is basically instantaneous because, unlike creating a snapshot, I'm not actually making a copy of anything. I'm simply marking my snapshot as bootable. So this should happen right away. So now we can go ahead and create new instances from this snapshot. So let's do that. So we'll close the VPC console page and we'll close our website. And let's start actually by simulating a failure. So what I'm going to do is stop my instance. And then we'll create a new instance in a new zone to take its place. Remember, snapshots, disk images, and elastic IPs are not bound to a single zone. ECS instances can't move between zones, but elastic IPs and images can. So I'll choose to shut this instance down, and then we'll go ahead and try and visit our website again after it's shut down. And then we'll create a new instance to take the place of this quote-unquote failed instance. So let's wait a moment. Okay, it's stopped. Now if I were to try to visit my website, it would fail. Sure enough, I can't get there. You can see that it's not working. It's just I'm waiting and waiting forever. I'm not going to be able to get to that page. So how are we going to fix things? Let's create a new instance, and then we'll move this EIP over to the new instance. So I'll click on Create Instance again, and we'll quickly go through all the steps we went through before. So I'll choose the pay-as-you-go type, and this time I'll choose a different zone. We'll put our instance in zone B. I'll choose the same instance type and family. I'll just put it in a different zone. So here we are. I've selected zone B. Again, we'll use a Gen 6e extra large. I will choose this time a custom image. So let's go ahead and choose a custom image here. Okay, custom image. I should only have one. It's my web server golden image. I'll leave the system disk settings alone. We will set up again a automatic snapshot policy for our new instance. Okay, we've selected our snapshot policy. Networking, same as before. I will not assign a public IP. We're going to move our elastic IP over. I will leave the vSwitch and VPC settings here. Again, we'll use the same VPC, just a different zone, Zone B this time. Security group, we'll use Singapore WebSG like before. We'll have one Elastic Network interface. Under system configuration, I can skip the password step this time. I can inherit that from the image, so I don't need to set that. But I do need to give this thing a name. Maybe maybe WebSG new. Okay, and I won't make any changes to the host name. I won't add any suffixes. Next, we'll go to grouping. Again, I'll leave all of those settings alone and move on to the preview. And it looks okay. Singapore Zone B this time, pay as you go, one ECS, using our custom image, and it's a G6 enhanced X large, just like our previous instance was. And I'll set it up to release itself automatically, and I'll agree to the terms of service, and then I'll click create, and that will create a new instance. And now I can close this tab, and from the console we can now see that I have two instances. Let's refresh that again. One of them is stopped, one of them is starting up. So one of the first things I want to do is take this Elastic IP off of my failed instance and put it back on my new instance that I've created from my image. So again, let's just double confirm that currently with my instance disabled, with my old instance shut down, I cannot get to the website. Then we'll move this IP over to our new active instance and things should start working again. So I'll go over to the EIP console again, we'll open a new tab, and I'll unbind the Elastic IP from its current instance and bind it to a new one. So I'll click unbind. Again, remember to click unbind and not release. Then I will go ahead and click on the Elastic IP, click on bind resource, choose ECS instance as before, and this time we'll bind it to our new web server, so the one that's running. I'll click OK, and the binding process is complete. This IP is now attached to our new instance in Zone B. If I go back and refresh, you can see the IP is moved up to our new instance in Zone B. Our Zone A instance is still sitting here turned off. And just to dramatically demonstrate how unimportant the original instance is to the custom image we just created, I can release this, and that won't have any effect at all on our ability to use that custom image we created. The instance image is not in any way bound to the instance that created the image. Okay, so our new instance now has the EIP bound to it. I should be able to copy paste that into a browser, and look at that, our site is back up in a new zone. So everything worked as planned. Thank you for joining me for the demo. Let's actually continue using the ECS from our previous demo. This is our ECS instance from our previous demo, which, as you'll remember, is running a little website for us. And currently, that instance has one disk. Let's try adding another disk to that instance. Remember, although cloud disks are a component of ECS, you can actually purchase and manage cloud disks separate from any one instance. And that's what I want to demonstrate to you now. I want to create a new data disk separate from this ECS and then attach it to the ECS afterwards. So let's go to Storage and Snapshots, and I'll click on Disks. And from here, I can actually create a disk independently of an ECS instance. So I'll do that. I'll click on Create Disk. That will take me over to the disk purchase page. My instance is in Zone B. Remember, your disk and instance have to be in the same zone to work together. So I want to create my disk in Zone B where my instance is. Let's create a PL1, 50,000 IOPS per second, and 100 gigabytes. I can choose to create it from a snapshot if I want, and I can turn disk encryption on as well if I want. I'll buy one, and we'll name the disk I'll call it Data Disk IO because it's a PL1, so it's a higher performance disk. I can add a description and some tags if I want. I can add it to a resource group. And then once I check the terms of service, I should be able to go to the preview page. This will give me some information about the disk, its name, its size, its type. When I'm satisfied, I can go ahead and click Create, and that will create my new data disk for me. Then I can go back to the ECS console. Specifically, from the disks page, I can now see all of my disks, including the new one that I've just created. You can see that it's unattached. So at this point, what I could do is attach it to an ECS instance. So See this more here? There's an option under more that says attach. If I click on that, I can choose to attach my disk to this instance here, WebSGNew. And then I can choose if I want to have this disk deleted when the instance itself is deleted. I'm going to leave that unchecked. I can also choose, if I've made snapshots of this disk, to have those be deleted when the disk is deleted. Again, I'm going to leave that unchecked as well. I want to give myself some recovery room in case I make a mistake. So I don't want my disk to be automatically released with my ECS, and I also do not want my automatic snapshots to be released when I release the disk. You can turn these on if you want. I'm not going to. I'll then click attach, and that should go ahead and attach my disk to the instance. It could take a moment to attach. If I refresh, you can see that it's now listed as in use, meaning it's attached to my instance. If I go back to the instances list and click on the instance ID, I should be able to go over to disks and see that I now actually have 2 disks. So I can see both of my disks here. So this is great, but there is a problem. The problem is that this data disk has been attached, but I haven't mounted it yet, and I haven't given it a file system. So to do that, I actually need to log into my instance and get a look at my block devices. So let's go ahead and do that. So I'll go ahead and log in. Oops, I need to go get my IP address. Then we'll SSH into this instance and take a look at our block devices. You can see that now I'm getting a warning. Why is that? Well, in the previous demo, I actually detached my Elastic IP from my old instance and attached it to a new machine. And that new machine has a different host identification than the old one does, so SSH thinks something bad is happening. It thinks maybe someone trying to trick me into logging into a Trojan horse of some kind, a machine that's different from the original. So what I'm going to do is go ahead and remove the contents of my SSH known hosts file and try again. Great. And then type in my password. Oops, just 1 second. Typed it wrong. And then there we go. We're in the ECS instance. So maybe we can get a list of our block devices. You can see that there's one block device here, dev VDA1. This is our 40 gigabyte system disk. I should have available to me as well an additional disk, the data disk, which you can see down here, dev VDB. Currently, this isn't partitioned or mounted or anything. I need to go ahead and do that now in order to use the disk. So what we need to do is use a command like makefs. So let's go ahead and do that. First, I actually need to go ahead and partition the disk. So let's do that. Oops. Oh, I typed SDB. Let's type in VDB. Okay. Let's get a list of help. So in fdisk, what we want to do here is, this doesn't need to be a bootable disk, so we won't toggle that, but I do want to create a new partition. So I can do that using M. So let's go ahead and add a new partition. It'll be a primary partition. It'll be partition number 1. Let's have it take up the entire disk. And now I have a Linux partition table on this disk, so I should be able to quit. So first I'll write the changes, and then I'll quit. Now if I go back to fdisk-l, you can see there's a partition, a primary partition on my new disk. So now we can go ahead and format this disk. So what I'm going to do is use one of the makefs commands. We'll make a new ext4 partition on dev VDB1. And you can see that we're now creating a journal, and that partition now has an ext4 file system on it, which means we can mount that partition and start doing stuff on this disk. So let's actually go ahead and do that. So let's see, I could choose to mount this disk anywhere. I'll just mount it in my home folder, data disk. And we'll do, again, let's list our disks. Okay, VDB1, and let's mount that on this new directory, data disk. So I'll say mount dev VDB1 on data disk. And if I now run the mount command, I can see I've mounted VDB1 on this folder data disk. And let's put a file in there. Great, so now there's a file on my new disk. let's unmount it. Alright, oops, I mean umount, sorry, should be umount under Linux. Great. It's now not mounted anymore. If I were to go into the data disk folder, it's empty because it's no longer serving as the mount point for my data disk. So the next thing to do would be to actually try removing the disk from this instance now that it's unmounted and attaching it to another instance, just to show you that the file is still there and that I can in fact move disks around between instances. So let's go ahead and create a new instance and attach the disk to that new instance. So before I do any of that, let's go back to storage and snapshots, go back to disks, and let's try detaching our data disk. So I'll click on detach, I'll click OK. I have already unmounted the file system, so it's safe to do this. Let's refresh, and you can see it takes a little bit longer to detach than it does to attach, but it should be done in just a second. We'll give it some time. While that's happening, we'll create a brand new instance. And this time I'll do things a little bit differently. Again, it has to be in Zone B because my disk is in Zone B. So I have to make sure the instance is in Zone B. But this time I'm going to choose an entry-level instance, a burstable type, because they're cheaper. So let's do that. Choose Zone B. Choose an entry-level instance. We'll choose one of the cheaper types. We'll choose a 5th generation T burstable instance with 512 megabytes of RAM and 1 vCPU. This is our cheapest type. These are quite low-cost instances. I'll go ahead and run Ubuntu on this instance. We won't. I can actually, if I want, attach the data disk from here, but I won't. I'll wait until later. I'll go to networking. We'll skip a lot of the configuration details because we want to just do this quickly. I'll give him his own public IP, not an elastic IP. Put him in the same security group as my other instances, the same VPC and vSwitch. He'll be in Zone B. System configuration, I will again choose a password. So let's choose ourselves a password here. Oops, gotta make sure I type it the same way both times. There we go. We'll call him disk test. Disk test. Grouping, we won't change anything on the grouping page. Automatic release, agree to the terms, and then create. So now we have 2 instances. So we'll try taking our disk off of our other instance and mounting it on this new instance. So I can close that tab. And here we are back on the instances list, and you can see that my new instance is starting up. So after waiting a moment, that new instance is running. Let's go ahead and log into it. So I'll take his public IP and plug that into the console. So let's log out of our original instance, log into the new one. Okay, so I can type in my password, get all logged in here, and we're now on our new instance, which is the disk test instance. So let's go ahead and attach our disk to that new disk test instance. So I'll go back to the disks part of the console. We'll list out all our disks. You can see I now have 2 system disks, one for my new one for my new burstable instance that I just created, one for my general purpose instance that I was using before, and then the unattached data disk, which I just removed from my general purpose instance. So for that disk, I'll click on attach, and I have to choose an instance, and I'll choose disk test, which is our new instance. Whoops, but we can't attach because that instance does not support eSSDs. So that's a problem. So our data disk is of a type that the Generation 5 burstable instance doesn't support. That's no problem. It just means that we have to recreate a new pay-as-you-go instance. And by the way, this is a good reason to use pay-as-you-go instances. If you had just created a subscription instance and then you discovered this problem, then that would be too bad because then you'd be stuck with the instance. So I'll fast forward through this creation process again. We'll make a Generation 6 instance, and then I'll pick up where we left off. We have now gone ahead and created a Generation 6 instance, which should be able to mount our eSSD disk. So some older instance classes don't support enhanced SSD, so we had to delete our previous burstable instance and make a new Gen 6 instance instead, which is now up and running here. So let's go ahead over to disks, and we'll go ahead and attach our data disk to that new instance. So I'll click attach. I'll choose my instance. Here it is, disk test. I'll uncheck both of these. I don't want to delete automatic snapshots. And then I'll click Attach. And if we wait a moment, that data disk should attach itself to our new instance. And once we mount it, we should see that it contains that file we created earlier. So from the console SSH into my new instance, this one here, let's grab that IP address. Yes, we want to trust this instance. Type in my IP, and here I am in the console. This instance is also running Ubuntu. So if I run fdisk, I can now see that I have two disks, my system disk and a data disk, and it's the 100 gigabyte disk that we just mounted. I'll create a new directory in my home directory called test, and I will mount dev vdb1 onto test. Let's see what happens. I go into test and I ls. Sure enough, there's my text file and it looks correct. So you can unmount and remount disks freely, moving them between ECS instances as long as those instances are in the same zone. And that's it for this demo. Thank you for joining me.